In this lesson, we're going to learn how to solve exponential equations and also how to solve logarithmic equations. So if you have an x in your numerator, we have learned that we have a special log property that if you have x log a, this is the same thing as log a to the x. So in order to bring that down, what we're going to do is we're going to take the log of each side. So watch, if I have log 5 to the x, if I took the log of both of the left-hand side, I need to take the log of the right-hand side as well. So what that's going to do is going to pull this x down to the base, not the base, but the front right here. So it's going to be x times the log 5 equals log of 81.2. So this is just x being multiplied by log 5. Log 5 is just a number. So I can divide both sides by log 5 to get the answer. So my answer is approximately, by putting this in my calculator, log of 81.2 divided by log of 5 is about 2.73. So if you have an x in your denominator, you can take the log of each side after you solve and get the base by itself. So for number 2, the base is by itself. There's just a 2. There's nothing around it. So what I'm going to do is I'm going to write 3x minus 4 out front. I'm already going to put it down, and this is going to be, take the log of each side, log 2 equals log 5. So I already accounted for this step where I took, I'm going to do that from now on. Instead of writing log 2, 3x minus 4 equals log 5, and then the next step writing it down, I'm just going to go right to this next step from now on. So now to solve for x, I'm going to divide both sides by log 2. So log 5 divided by log 2 is just a number. So I'm going to hold this number in my calculator. So I'm going to do log 5 over log 2, and that's equal to 3x minus 4. So to solve for x, I'm going to do log 5 over log 2, close the parentheses, add 4 in my calculator, and then once I get that number, divide by 3. So I want you to, instead of rounding and rounding and rounding, I want you to hold this in your calculator to get the answer. Okay, number 3. I need to isolate the base first, so divide by 16. So 3 to the x minus 5, and this actually is a number that doesn't have a repeating decimal. It's just 57.8125, so I don't have to do any rounding. Now I'm going to take the log of each side, so it's x minus 5 goes out front, log 3 equals log of 57.8125. So now I'm going to get the x minus 5 by itself by dividing both sides by log 3. So I'm going to have x minus 5 equals this quantity right here. So I'm going to do this in my calculator, close the parentheses, and then add 5. In this I get about 8.693, depending on how you're asked to round. This is rounding to the thousandth. And then number 4, this time we have a log equation. So if when you have a log equation, you try to get the log by itself. So if you look, there's nothing over here on the log, there's no number out front, you're not adding a number. So what I'm going to do is, I'm going to write this as a base 10, so it's 10 to the negative 1 equals 2x. So what is 10 to the negative 1? Well, that's just 1/10 equals 2x. So to solve for x, divide both sides by 2, So x equals 1/20 is the answer. So if you have a logarithm, get the log by itself, isolate the log, and then write it as an exponential equation. So this one, log is by itself. There's no constant. There's no coefficient. So I'm going to write this as it's base 10. So it's 10 squared equals 3x plus 1. So 100 equals 3x plus 1. Subtract 1, you get 99. So x has to equal 33. And then number 6. This is where I have a log out here, so I'm going to divide both sides by 2. So log of x plus 1 equals 5/2. So this is going to be 10 to the 5/2 equals x plus 1. And then, so 10 to the 5/2 is just a number. I can put that in my calculator, or I can do the 10 to the 5th and do the square root of that, but that kind of turns out to be complicated too. So I'm just going to subtract 1. So, and put that into nearest, I'll do 10th, is 315.2. So remember that 10 to the 5/2 is the same thing as the square root of 10 to the 5th, or 10 to the 5th, and then take the square root of it. So 10 to the 5th is going to be 1, 2, 3, 4, 5. So you're taking the square root of 100,000, which you could break down. And then number 7 is I want to write this as a single log. So think about doing the properties of log from 8.4. So I have this 3 out front. That's going to turn into my exponent. So it's going to be log x cubed. And then you're subtracting, so this is going to be your denominator, over 2 equals 5. So now this is base 10, so it's 10 to the 5th equals x cubed over 2. So 10 to the 5th is 100,000, so multiply it by 2, so you're going to get 200,000 equals x cubed. And then you can take the cube root of both sides. So the cube root of 200,000 is about, I'm going to do it to nearest hundredth, 175.44. So just make sure you read what you're supposed to round to. Or if you leave it in exact form, exact value of this, you'd have to break out into groups of 3, 200,000. And then number 8, you want to write it as a single logarithm. So this is adding, so I'm going to multiply these two. So it's log of x times x plus 1 equals 3. So this is log of x squared plus x equals 3. So now I'm going to write it as 10 to the 3rd power equals x squared plus x. So now I have a quadratic. So I'm going to get one side equal to 0, so it's x squared plus x minus 1,000 equals 0. So I could try to solve by factoring, which I can't not think of. I don't think there are factors of negative 1,000 that add up to 1. You could solve it by graphing. If you could use your calculator, you could look at where it crosses the x-axis, or you could use the quadratic formula. So if I do the quadratic formula, a, b, c, I get negative 1 plus or minus the square root of 4ac, or b squared minus 4ac. So 1 minus 4ac is going to be positive 4,001 over 2. So I'm going to have, it looks like I'm going to have a negative answer and a positive answer. So I'm only going to take the positive because I want x to be a positive number. Because if I have log x remember, in order for this to be defined, x has to be at least, or it has to be greater than 0. Because, remember we tried to do log, let's say negative 25 is in one of our exercises. So we thought of, okay, 10 to the what power is negative 25, and we couldn't get anything, so that couldn't be a negative number. So my only positive answer is going to be exact -1 plus the square root of a 4001 over 2, which is approximately equal to 31.13. So I'm only taking the positive. And then next part, solve by graphing. So what you want to do when you're solving by graphing is you want to put the left-hand side in your y1 in your calculator and the right-hand side in your y2. And it doesn't matter if you put this in your y2 and this in your y1. So then what you're going to do is you're going to graph both of these functions. So y equals 5 to the 3x is an exponential growth function that's very steep. So it's going to look something like this. It has a y-intercept of 5. And then y equals 500 is just a horizontal line. So if you're graphing this and you're not able to see your function, just make sure that you actually have your window proper. So for my window, if we're going to go to y equals 500, I think I might have said 5,000 before, but if you're going to y equals 500, you need to have your x min maybe at 0 and your x max needs to hit 500, maybe like 600. Not x, sorry, I should have wrote y. So your y going up and down should start at 0 and go up to 600. Just make sure you're including 500 in that interval. So then what you do is you use your second trace, intersect, and the computer calculator is going to ask you to go on your first curve and your second curve, and it's going to ask you to guess, and you're looking for the x-coordinate. So when I do that, I get an x-coordinate of approximately 1.29. So that's my solution, approximately 1.29. And then number 10, evaluate using the change of base theorem. So the change of base theorem is if you don't have a base 10, you can put this in your calculator by doing log 15 divided by log 3. So I remember that because the base is always going to be on the bottom. So if you just put in your calculator log 15 divided by log 3, you're going to get a decimal. By the way, this is not the same thing as log 5. That's a common mistake of people just crossing these out and put 5. It's not. You have two logarithms right here. It's different. So if you had to do log base 2 of 17, you would put the base on the bottom, so it's log 2, and log 17 is going to be your numerator. So this does not equal log of 8.5. Nope, because you have two logs right here. So put that in your calculator.